GraphQL allows developers to communicate with all of their different backends through a consistent query interface. A GraphQL query can be translated into queries to MySQL, MongoDB, ElasticSearch, or whatever kind of API or backend is needed to fulfill the GraphQL query. GraphQL users typically need to set up a GraphQL server to fulfill this query federation to the different data sources. Prisma is a tool for automatically generating a GraphQL API and resolving and serving GraphQL queries. The developer defines a data model and deploys with Prisma. Prisma generates the necessary GraphQL infrastructure to resolve and serve those queries from the developer's data sources. Using Prisma can allow the developer to get up and running faster than they would if they had to set up GraphQL infrastructure themselves and define that middleware query layer by hand. Prisma is an open source project, but it's also a company. The opportunities to build a business around a GraphQL infrastructure layer are numerous. In recent episodes, we've explored the complexities of the data platform. From newer companies like Uber to older companies like Procter & Gamble, engineers are struggling to find and access their data sources. Data engineers and data scientists spend months configuring their infrastructure to connect to BI tools and run distributed queries. GraphQL could simplify data platforms by providing a unified, standardized layer. At this layer, you could also offer things like caching, virtual data sets, and crowdsourced queries from across your company. Soren Bramer Schmidt is the CTO and co-founder of Prisma, and he joins the show to discuss why GraphQL has become so popular. And he also talks about why Prisma works and the opportunities to build developer tooling around GraphQL. This was a great show. I'm really interested in Prisma and the GraphQL community more generally, so I look forward to doing more shows in this space. Before we get started, I want to mention that we are looking for writers. We're scaling up our written content, and we're also looking for podcasters. So we are hiring for both of these roles and several other roles. You can find them by going to softwareengineeringdaily.com/jobs. I'd love to see your application. DigitalOcean is a reliable, easy-to-use cloud provider. I've used DigitalOcean for years, whenever I want to get an application off the ground quickly. And I've always loved the focus on user experience, the great documentation, and the simple user interface. More and more people are finding out about DigitalOcean and realizing that DigitalOcean is perfect for their application workloads. This year, DigitalOcean is making that even easier with new node types. A $15 flexible droplet that can mix and match different configurations of CPU and RAM to get the perfect amount of resources for your application. There are also CPU-optimized droplets, perfect for highly active front-end servers or CI/CD workloads. And running on the cloud can get expensive, which is why DigitalOcean makes it easy to choose the right size instance. And the prices on standard instances have gone down too. You can check out all their new deals by going to do.co/sedaily. And as a bonus to our listeners, you will get $100 in credit to use over 60 days. That's a lot of money to experiment with. You can make $100 go pretty far on DigitalOcean. You can use the credit for hosting or infrastructure, and that includes load balancers, object storage. DigitalOcean Spaces is a great new product that provides object storage. And of course, computation. Get your free $100 credit at do.co/sedaily. And thanks to DigitalOcean for being a sponsor. The co-founder of DigitalOcean, Moisey Uretsky, was one of the first people I interviewed, and his interview was really inspirational for me, so I've always thought of DigitalOcean as a pretty inspirational company. So thank you, DigitalOcean. Soren Bramer Schmidt, you are the CTO and co-founder of Prisma. Welcome to Software Engineering Daily.
Thank you, Rafi. It's great to be here.
So Prisma is a open source project that is related to GraphQL, and I'd like to ease into an explanation of Prisma by starting with GraphQL. I think most people listening to this are faintly aware of what GraphQL is, at least, and if they're not, they can listen to some other episodes. But maybe you could start with just explaining why GraphQL became popular. Why is this thing useful?
Absolutely. I would start by saying this. If you're not super familiar with GraphQL, go and make yourself familiar. It's quite a big change to how you interact between clients and servers, and it is really rising in popularity at the moment. So where does GraphQL come from? GraphQL came out of Facebook. They had this problem that they were building their mobile app, and they were structuring their teams in such a way that you had a bunch of different backend teams, and then you had like a very small front-end team. And what they faced is all the normal issues you have when you query a REST backend. You do multiple round trips, your applications get slow, and you write a lot of boilerplate code to deal with all of this. So most companies, they go through a phase where they see, oh, it's quite messy what we have here. How do we clean this up? So they start imposing standards or restrictions to the way that they develop their REST API endpoints. And what GraphQL is really just a formulation of those standards. All the best practices that people have developed over time in REST APIs, it is written down into a nice cohesive spec that is maintained by Lee Byron from Facebook. And because this is now a standardized effort, you see many companies, many community members rallying around this one standard and creating shared tools that everybody can benefit from. So that's kind of how you should think about GraphQL. It's all the good parts from REST standardized in a way that the community can work together.
At a typical company, you have various teams that are working on various parts of the product, and the communications between those different teams may not be as fluid or as friendly as at a company like Facebook. At Facebook, I can see how there could just be this virality of GraphQL propagating through an organization and people latching on to GraphQL. How does the adoption work at a more typical company? When does a typical company start using GraphQL?
So it's really interesting, actually, when we go out and talk to some of these bigger companies that have some of the issues you're alluding to. You could call it infighting, or probably just really teams trying to protect themselves. What you see is that the adoption of GraphQL is typically driven by front-end teams that are creating mobile apps or websites, and they are tired of having to deal with this sprawling REST API that just ties them down. One thing is the performance benefits you get from using GraphQL, but the other thing is just the speed and agility you have, because you can start writing your data requirements in this declarative language instead of having to maintain a bunch of different API calls and synchronize it all. So what you often see is the front-end team will either embed a GraphQL server directly in the front end and ship it to the browser, or they will set up their own proxy GraphQL server that does just one thing. It accepts an incoming GraphQL query, and then it has the responsibility to delegate to all the existing backend services.
So what about the differences between like a big company that's already established and they're trying to onboard with GraphQL versus a startup that is starting a greenfield application and they're having GraphQL from day one? How do the user experiences of those two types of companies compare?
So one thing is implementing GraphQL when you have a big system already. When that is your perspective, then you typically try to just wrap the existing system. But when you're starting from scratch and you're a little forward looking and you think, hey, we're going to do GraphQL. So do we really need to build REST APIs? Do we really need that? Maybe you do, but many companies find that they don't. So those are the companies we call GraphQL native. They start with a GraphQL mindset from the beginning, and they build their microservices and the API endpoints as GraphQL. And what we have found really useful is a technique called schema delegation that allow you to take a subset of a GraphQL schema and delegate the responsibility of resolving data for that schema to other services. And one way you can do that is to say a subset of a schema is being delegated to a data service that is implemented on top of Prisma, for example. So we see a lot of small companies starting like this, And we can get into the details a little bit later. But what that allows you is to get an initial service up and running really, really quickly. And then as you grow in sophistication, you can slowly peel off layers and start adding more complexity into the system. That's probably a fairly abstract explanation. But the main point is that when you start from the beginning, thinking you want to do GraphQL, you can get a lot of benefits by architecting your application with that in mind from the beginning.
Let's review quickly what happens in a normal GraphQL query. So if I am a front-end developer and I issue a query to my backend GraphQL system, what happens? What does that query look like, and what are the different steps involved in processing and returning the results for that query?
So first of all, you need to understand what is the structure of a GraphQL query. So a REST query is for one particular endpoint, for example, users, get me the user entity with a specific ID. That's a REST API. And if you need, let's say, 2 users and you need all the posts from that user, you end up making at least 4 calls, right? In GraphQL, that is not the case. In GraphQL, you are submitting a tree-structured query. You can think of it as a JSON document, just containing the keys, not the values. And then it is the responsibility of the server to take that this GraphQL query and fill in all the values. So that means you are able to traverse relations in the query. So then just look at how does that work on the backend, on the server side. Well, the server gets this query, it has to parse it, of course, and there are libraries in all the popular languages, very well-maintained libraries. So you parse this query, and then you have what is called a resolver system. So you, as a backend server developer, you don't have to deal with parsing queries and figuring out how to do all of this efficiently. What you do is you implement a resolver for every part of your schema. So you implement a resolver that knows how to get users, another resolver that knows how to get posts from the user. And then GraphQL server implementation, the resolver system will take care of executing one of those resolvers in a batched fashion to execute the entire query and get all the data in the most performant way.
There's a part of setting up a GraphQL system that requires you to set up something called a GraphQL schema, or define a GraphQL schema. What is a GraphQL schema?
So this is super interesting. In the early days of GraphQL, the GraphQL schema was a little bit abstract. You would create the GraphQL schema by essentially writing code. So the GraphQL schema was not something you could point at and say, there's my GraphQL schema. But then about a year ago, a little more maybe, there was an addition to the GraphQL specification called SDL, so it's the schema definition language. And SDL is a very concise syntax for expressing a data model, essentially. So think about something like a UML diagram, but it's text, and there's very little visual clutter. So it's a really nice way to represent what is your domain model, what does it look like? So you write type, open brace, then all the fields, the types of those fields. And if the type of a field is not a scalar, it could be another type. So you express relations this way. And what we have found is that many companies find it really, really useful to use this schema definition language as a way to communicate between engineering and business people. Because you can sit down together and very quickly write out, this is what I think our domain look like. And business people can look at it and say, oh, that makes sense. Or actually, you're missing like an intermediary over here. Let's try to move it around a little bit. And there is tooling that can take this schema definition and turn it into a graph, so you can look at all the interactions. And there are tools like Prisma that can take an SDL and turn it into a real running GraphQL API backed by a database. So this aspect, this standardized tooling, makes it super easy to very rapidly iterate on your product and get real feedback while you're sitting there with the domain experts.
Does the schema definition, does that define relationships between different databases on your backend, or does it just define, is it a schema per database?
So this is where we need to really distinguish between GraphQL as a technology and Prisma as an open source product. GraphQL in itself has no relation to databases or anything like that. It is completely agnostic to how the implementation looks like. GraphQL is the schema that defines relations between abstract entities without knowing what they are backed by on the backend, and it is the resolver system. Now, Prisma is a way to construct a GraphQL API on top of databases. So in Prisma, you can say you have an existing MySQL database, a Postgres database, or Mongo database. And then you can write SDL that maps this database to the GraphQL API. And in Prisma, you create different schemas for individual databases. So let's say you have a MySQL database and a Mongo database together. Then you would write two different schemas that would expose those databases as two different GraphQL APIs. In the future, and this is a thing I'm really excited about, in the future, we will make it possible to create relations in the SDL between different databases so that you can link directly between, let's say, a Postgres database with users and an Elasticsearch database, for example, with indexed posts. This is a thing that people very often do when they complex web applications. They need to store data in different kinds of databases because you need the different query capabilities from different databases. So you are maintaining syncing between all of these databases. Towards the end of the year, we will start working on features in Prisma to make this much more seamless and deal with all of that for you.
OpenShift is a Kubernetes platform from Red Hat. OpenShift takes the Kubernetes container orchestration system and adds features that let you build software more quickly. OpenShift includes service discovery, CI/CD, built-in monitoring and health management, and scalability. With OpenShift, you can avoid being locked into any of the particular large cloud providers. You can move your workloads easily between public and private cloud infrastructure, as well as your own on-prem hardware. OpenShift from Red Hat gives you Kubernetes without the complication: security, log management, container networking, configuration management. You can focus on your application instead of complex Kubernetes issues. OpenShift is open source technology built to enable everyone to launch their big ideas. Whether you're an engineer in a large enterprise or a developer getting your startup off the ground, you can check out OpenShift from Red Hat by going to softwareengineeringdaily.com/redhat. That's softwareengineeringdaily.com/redhat. I remember the earliest shows I did about Kubernetes and trying to understand its potential and what it was for, and I remember people saying that this is a platform for building platforms. So Kubernetes was not meant to be used from raw Kubernetes to have a platform as a service. It was meant as a lower level infrastructure piece to build platforms as a service on top of, which is why OpenShift came into manifestation. So you can check it out by going to softwareengineeringdaily.com/redhat and find out about OpenShift. So it sounds like today, the primary use case of Prisma is to be some sort of presentation layer in front of... Well, maybe you could just re-explain what Prisma is. What kind of problem is Prisma trying to solve today?
Yeah, absolutely. So the way to think about Prisma is as a data layer for your application. So whenever you need to deal with databases, you need to store data. When we go and talk to what we call like rocket ship companies, like modern high-scale technology companies like Google, Facebook, Twitter, companies of this kind, they all have built a thing internally that you could describe as a data layer. And the purpose of this data layer is to really abstract the database away from the application developer. When you're working with a database directly, you have a lot of power in your hand. You can do a lot of good stuff, but you can also do a lot of bad stuff. And it's actually really complicated to deal with. So when you want to move really fast, you want to give capabilities to your application developers that is above what normal databases provide, you introduce a middle layer. That's what we call the data layer. Most normal companies, small companies or big enterprises, they don't have this kind of thing because they can't afford hiring a team of the best engineers in the world to just go and build a data layer that is special tailored to your needs. So what we're really trying to do with Prisma is to go to all of these big companies, the technology companies, the rocket ships, and learn from them and say, what did you build into your data layer? And why is that useful? And can we find common patterns and abstract that out into an open source product that we can make available to a much wider group of companies? So that's a fairly abstract way to talk about it, but does that make sense?
Yeah, and tell me if this is accurate. So my understanding of what Prisma does is if I'm setting up GraphQL without Prisma, I need to define how a GraphQL query gets translated into a MySQL query or a Mongo query, because the whole idea is that if I'm a front-end developer, all I have to learn is GraphQL, and then the GraphQL middleware infrastructure takes care of translating that GraphQL query into queries, a query for Mongo or a query for MySQL, or potentially a query for both of those, and a way to join those two database queries together. And as an application developer, I just get back the data, and I don't care about what kinds of query writing had to be done in order to get that data back. Now, with just normal GraphQL, I would have to write the translations of each of those GraphQL queries into their respective database translations, but Prisma is able to derive the schema of the databases and do translation from GraphQL to the database queries automatically. Is that right?
So that is right, but it's not the entire story. So it's very important to realize that you're not supposed to query Prisma from, let's say, a React app or from a mobile app. You can do that, and you can even set up permissions to make that sane, but that's not how we envision people will use Prisma. That's not how most of our customers are using Prisma. What you do instead is you query Prisma from your own GraphQL server. You typically want to have a server that implements business logic or some kind of authorization mechanism. But then because Prisma exposes GraphQL and you're implementing a GraphQL server, you can take advantage of that direct mapping. I mentioned this earlier. It's called schema delegation. It's an advanced feature that allows you to basically expose a subset of your GraphQL schema by delegating to another GraphQL schema. This is a very advanced use case, and it's great when you need it. But most people, even when implementing a GraphQL server, actually just uses Prisma. You might have used an ORM in the past to resolve data. So think of Prisma more as a layer in between your database. Maybe forget for a moment that it uses GraphQL as the wire protocol, but just think about it as a logical component that you talk to whenever you need to modify or access data.
So does Prisma itself need to figure out these database schemas, like the schemas of the underlying database? Like, does Prisma do introspection into the databases to figure out how to translate GraphQL queries?
So there are two ways you can work with Prisma. You can either work with Prisma from scratch. Let's say you're building a new application, you don't have any databases already. Then you can use what we call declarative migrations. You basically, instead of doing database migrations, you're writing out the GraphQL SDL, the schema definition language. This super easy to read and write textual format that describes your data model. And then Prisma is able to make a diff between your previous data model and your new data model and tell you the user type has changed. There are 2 new fields, and this field was renamed. Do you want to execute those changes? So you can use Prisma to migrate your underlying database. If you have an existing database and you don't want to use the Prisma migration system, then you can let Prisma introspect your database, and Prisma will then generate a data model that fits that database. You're still in control and can remove some parts of it. Let's say you have like a legacy, very complex Oracle database, and you don't want all of that exposed to application developers. You can do an initial introspection of the database, and you can then go and remove a bunch of fields or tables and just expose the data model that you want to the application developers.
Let's look at Prisma through another angle. There is a term that people have used for a long time called ORM, Object Relational Mapper. What is an ORM, and how do people typically set up their ORMs?
This is a great question. So people have dealt with databases since forever, right? And if you use a relational database, you're typically interfacing with it through SQL. So you would write SQL queries. And what people found is that it's very tedious to write all of those SQL queries. You don't get a lot of help from your development environment, and there is what you call an impedance mismatch between your typical object-oriented language and the relational algebra of the database. So what people came up with is the object relational mapper, the ORM, that basically translates your nice object-oriented world in your programming language, let's say Ruby, to the world of relations in the database. So in Ruby on Rails, for example, you have active record. And it's a fairly sophisticated system that allow you to deal with all your business entities as if they are objects in memory. You can add things to relations by pushing onto an array. You can just update fields, and then when you tell this object to save, or when, let's say, the request is over, you could configure the active record to automatically persist to the database. So this is a very nice model from a development perspective. But it has some problems. When you use an ORM in a small application, it's great. But then as you grow, you run into all kinds of issues. It's very easy to end up with an architecture where you have these active ORM objects that can talk to the database, and you're passing them around, and all of a sudden you have calls to your database from all kinds of different places in your application logic. And it gets difficult to reason about the performance implications of that. So what you very often see is, as applications grow, people try to push back the ORM to create a new logical layer in the application that you could call a data access layer or something like that, and make sure that the ORM objects never spread from there. And when you get to that point, many people say, why do we even need the ORM? Could we just write raw SQL? It would be much simpler. So I think ORMs are really used a lot in simple applications, but as people get more and more sophisticated, they pull back from the ORM.
How does Prisma compare to the usage of an ORM?
So on a high level, it's fairly reasonable to think of the Prisma client as an ORM. It's the same basic functionality. You retrieve data and you store data. But because the Prisma client is modeled GraphQL, you are to think about when you load data and when you store data. And when you do load data, it's very simple for you to load all the data you need. You can traverse relations and make sure that you get all the data that is required for the computation you're about to perform in one go. So that avoids the typical problem of ORMs where you would either fetch too much data or not fetch enough so that you need to go to the database in multiple rounds. The Prisma client makes it really easy for you to think through what you need to do and basically lay out your computation in the right order. First, load your data, do your computation, then store your data. So from that perspective, Prisma really helps you enforce a sane architecture.
Why is it called Prisma?
So I think the initial idea is Prisma is the German word for prism. And what does a prism do? You have a beam of light coming into the prism and it spreads out. So the idea is you have this one GraphQL query coming in and Prisma spreads it out and sends it to the correct databases and assembles it all back together again.
Now that we have revisited several different areas of Prisma in more detail and some different areas of GraphQL in more detail, let's revisit one of the questions that I asked you earlier. So a GraphQL query without Prisma versus a GraphQL query with Prisma. Contrast those two things.
So building GraphQL servers is actually pretty hard. I mentioned in the beginning that you would do batching of different resolvers to make sure that you resolve the query in the most effective way. So,
by the way, what's a resolver?
A resolver is the piece of code that you create to return the data required for a subset of the query. So let's say you have a data model, schema definition language model that contains users and posts. You would then write a resolver to get users, and you would write another resolver to get posts. So let's say you have a query that gets a specific user and the first 10 posts. The most naive implementation of this would first resolve the user, get the user, then go and get all the posts for this user. And what happens then if for each of the posts you also need to get comments? Then for the 10 posts, you might go out individually and do do an additional request. This is bad for performance. You should not do this. So the way you deal with this, the way all GraphQL APIs deal with this is that they implement what is called the data loader pattern. So instead of going to the database immediately when you see that you need to request some new data, you put the data loading request on a queue. And then after a little while, you look in that queue and you say, oh, I need to get 10 comments for 10 different posts. Let's batch all of this together and go to the database with one request. So normally when you implement a GraphQL API, you need to do all of this yourself. There are libraries to help you deal with it, but you need to do this correctly in your resolvers. If you use Prisma, you use the Prisma client to implement your resolvers. It already implements the data loader pattern. So that means when you implement a resolver, you only need to think about how do I query the correct data here and what kind of transformations do I want to do. You don't need to think about any of the infrastructure to make sure that your GraphQL API, your data access is fast. That is built into the Prisma client. So that comes for free, basically.
So in terms of translating a query into the target database, what is Prisma doing to help make that translation easier?
So what Prisma does is it exposes this very rich CRUD API as a GraphQL schema. So you can use a subset of this API in your resolvers. And that means you can basically expose just a subset of the API exposed by Prisma in your application GraphQL API. So by giving you all of these building blocks, that is a very direct match to the GraphQL API you want to implement. You can very often take shortcuts. So remember I talked about the impedance mismatch before, the mismatch between the relational model in the database and your object-oriented model in your programming language. When you have GraphQL on both ends, you don't have this same kind of mismatch. And the GraphQL results map very neatly to objects anyway, because the result of a GraphQL query is just a tree. It's a tree of entities. So it's very easy to represent that as objects in your programming language. So it's really, it frees you from thinking about all of the stuff you need to think about when you have a relational database.
Such as what? What's an example of something that I would have to think about with using a relational database that I would not have to think about if I was using Prisma?
So if you write raw SQL, then you have multiple different tables, and you probably have relations between those tables. That's how you make them useful. So you need to now join those tables. So what happens when you do a single join is that you have one table, you have a key in the other table. Let's say you have the user table and you have the comments table. Then in the comments table, you would probably have a user ID that creates a reference from comments back to users. And to get a user and all of that user's comments, you would now join those two tables. And when you think about that, it's like you create a giant spreadsheet with a lot of duplicated data. And then many application developers probably don't think about this, but it's kind of weird. And when you start doing relations across more than two tables, it becomes pretty messy. And that's why you have this entire category of ORMs that try to deal with all of that. Try to do these joins, then look at all the data, remove all the duplicate data, get it back into a sane object structure that you can reason about as a developer. But if you discard the ORMs and you go directly to the database, it's pretty complex to reason about. And now contrast that with the world of GraphQL. The mental model that GraphQL puts on you is exactly the mental model you care about. You want to specify a tree structure of the data you care about, and you want to get that data back as a tree structure. So you get the one user, you get the comments are an array. From the comments, you can then traverse other things. Those other things would be objects or arrays. So it's a very natural model compared to relational databases.
Prisma is compatible with some particular databases. So you have to write some kind of integration with each of the databases that it's compatible with, right? Like you have to write some compatibility layer between Prisma and MySQL and with Postgres and with Mongo. What is that compatibility that you write with these integrations?
That's correct. So Prisma is open source. You can go have a look in the repository. It's there's a lot of code in there, and one major push we have right now is implement connectors for more databases. So you're correct. We currently have connectors for MySQL, for Postgres, and for Mongo. And what does a connector do? Well, a connector knows how to implement those resolvers I talked about before for a specific database. So let's say you have a single table called user, then there would be one resolver to go and get a particular user. There would be a resolver to go and get all users. And there would be a resolver to get posts that are related from that user. So that's what the connectors do. They resolve data from a database. What they also do is they migrate a database. So remember I said we have this declarative migration system that basically produces a diff on your data model to see what has changed, and then performs those migrations on the database in the most efficient way. And then, of course, those connectors do all of this in a very efficient way. So all the data loader patterns, all the chunking and grouping happens in Prisma. So what we are working on over the next 4 or 5 months is to add many more database connectors. An example I gave earlier was ElasticSearch, which I'm personally very excited about because so many companies we go and speak to, they do this exact thing. They store most of the data in a relational database, but they need to have search. They need to have fast, sophisticated full-text search. And how do you do that? Well, you copy all of the data to ElasticSearch, and then you need to maintain this entire syncing system. And now your engineers need to not just deal with relational databases, but also deal with Elasticsearch. You add an entire new variable to the mix. And what is so great about mapping all of this to one paradigm, to GraphQL, is that not just is the mental model better, it's the same mental model that you can apply to all the databases. So in the future, when we have search databases, we have relational databases, we have graph databases, you as an application developer can switch between all of them without having to learn a new driver, learn a new mental model, learn about the quirks of hosting a particular database. You can just go and use the GraphQL playground, and you can explore the API that those databases provide in a very familiar, very easy to explore way with auto-completion just by writing GraphQL queries.
Your audience is most likely global. Your customers are everywhere. They're in different countries speaking different languages. For your product or service to reach these new markets, you'll need a reliable solution to localize your digital content quickly. Transifex is a SaaS-based localization and translation platform that easily integrates with your agile development process. Your software, your websites, your games, apps, video subtitles, and more can all be translated with Transifex. You can use Transifex with in-house translation teams, language service providers. You can even crowdsource your translations. If you're a developer who is ready to reach a global audience, check out Transifex. You can visit transifex.com/sedaily and sign up for a free 15-day trial. With Transifex, source content and translations are automatically synced to a global content repository that's accessible at any time. Translators work on live content within the development cycle, eliminating the need for freezes or batched translations. Whether you are translating a website, a game, a mobile app, or even video subtitles, Transifex gives developers the powerful tools needed to manage the software localization process. Sign up for a free 15-day trial and support Software Engineering Daily by going to transifex.com/sedaily. That's transifex.com/sedaily. I can imagine in a multi-database infrastructure, you might have several different databases that could potentially satisfy your query. And if GraphQL and Prisma are taking care of translating your query into each of those different databases, you could have the GraphQL Prisma infrastructure take care of figuring out which database is actually the best fit for a query?
Now it gets really exciting, right? Because Prisma is a stateful component that sits between the application and your databases. So it knows about everything that is going on. It sees all the queries, sees all the traffic. It can keep statistics over time and see how do particular queries perform. It can look at the amount of data. It can look at indexes in the database and say, I'm recognizing some queries that are slower than they should be. Maybe we could suggest to the application developers to apply particular indexes, or maybe we could suggest to the application developer that they introduce a new kind of database, use Prisma to pre-aggregate results into this database and perform these queries through that database instead. If you go and talk to many of these large-scale internet companies, you'll see that they often have something similar to CQRS. So CQRS is, the idea is that you separate your read model from your write model. You basically have two completely different data paths. One is to write changes to a transactional system to make sure everything is nice and consistent. But then you have the read path. And the purpose of splitting up those two paths is that you recognize that most of your traffic, often like a factor of 100 or 1,000, most of your traffic is read traffic, not write traffic. So it makes sense to optimize those two paths separately. So the system you often come up with is you have your relational database on the write path, and then you pre-aggregate views of this data, including summations and joins and all this stuff. And you take that complex result and you store it in maybe a document database like Mongo, where you can basically store all the data you need to serve a particular query. And what we find is when we go and talk to all of these companies that do this, it's massively complex and there are no good systems to deal with it. They all build their own complex systems internally that they are now the only people in the world who know how to operate. When they hire new people, they need to train them from the beginning. And really, they're all quite different, but they're doing the same thing. So there should be a standardized way to deal with all of this. So down the line, when Prisma has support for many more databases, when we start seeing adoption, it makes sense for us to really try to make this pattern much more accessible to not just big technology companies who can build their own infrastructure, but to all application developers. This is a tool that should be available to everybody building internet applications.
So in terms of the check boxes that we've talked about Prisma potentially satisfying, we've got simplifying the queries for application developers that are writing services. We've got allowing joins between simplifying and allowing joins between different databases. We've got query recommendations. We've got potentially caching. You didn't really explicitly mention caching, but caching could be, or I guess you did kind of, because in the suggestion, like Prisma says, hey, this query would run a lot faster if you inserted this Redis and then you start caching your stuff, and we can do all that for you. Would you like us to set that up for you? Just click this button and you do that, and that would be a really cool, smart, futuristic data layer. The thing that we haven't really touched on is data science, data infrastructure, machine learning. These things are also tied to the data problems that companies have. We've had shows with companies like Dremio and other companies that are tackling this data infrastructure problem, or an Uber. Like a recent show that I did that has really stuck in my mind was about Uber's data infrastructure and their ETL pipeline, and their getting their transactional data, like the my rides that are going on right now, translating that, pulling that data into a data lake, and then pulling data from that data lake into Elasticsearch, or pulling it into Presto, and making it available to data scientists and data engineers that are building on top of Uber's data platform. Because there's so many people at Uber, they need this big data platform to be able to not only write like microservices and have, like you said, that ability to have a really fast and responsive read pattern, but the ability to do ad hoc machine learning jobs and analytics and stuff related to billing. And there's so much that goes on top of the data platform that is not directly related to the sort of microservices applications that we're talking about. So how are you evaluating the opportunities of the data platform, of the machine learning and the data science suite of applications?
I like the term data platform. So first of all, it's important that we are not building a database. We definitely not building something that would sit directly on a desk and know how to store data. We are a layer on top of existing databases. That's super important to keep in mind. The other thing is we are definitely not building something for Uber to consume. They're too big. They have very specific needs, and they can hire teams to work on something, and it makes sense for them to hire teams that work on something that is very specific to their needs. What we are rather doing is we are looking at the patterns that emerge at big companies like Uber, and we try to productize it. We build an open source product around that maybe less sophisticated is not the right way to say it, but more normal software teams can use to build out their infrastructure. I think data platform is interesting because you don't really want to just be dealing with databases. You don't actually care that much about databases. You care about your data, and you care about that data being available to your application engineers, your data scientists, whoever are in your organization and should have access to this data. So next to Prisma, the open source product, we are also working on related software we call Prisma Cloud and Prisma Enterprise. So those are basically like a platform on top of the open source Prisma. So what this platform gives you is a way to manage access to all of your databases, to manage access rights, who can change data structures. You have a history of what different employees are doing. And this is also where we will introduce many more aspects in the future, such as like analytics, the kind of suggestions we talked about before. I'm quite curious, though, why you create data platform to machine learning and these kind of things. I obviously haven't listened to that particular podcast, but maybe you have something particular in mind there.
Well, if you have to train a model and you want to train that model on the last 4 years of rides at Uber, you need a way to get all that data from your data lake into your training system. And so
right. Okay, I get what you're getting at. So you have transactional applications like a web server, and it can do a lot of requests. It reads and writes a lot of data. And what is important for a web server is low latency, not so much throughput. But when you're dealing with tons and tons of historic data because you want to do machine learning, you want to train your models, then it's the exact opposite. Latency is not really that important, but throughput is important because you have just terabytes and terabytes of data to push through.
But this is a false dichotomy, because in the future, you're going to want models that update really quickly, and models that update really quickly, even based on large influxes of recent data. So if you have 5,000 cars on the road, 5,000 self-driving cars on the road, they're constantly pulling in lots of data, and you want the models that are being built off of those data to be updated really quickly. Then you actually have high volumes of data where you want those to be piped into different services really quickly. So it's like a false dichotomy that exists today, but probably will get changed in the future.
Okay, yeah, that makes sense. So one thing we're definitely seeing when we talk to bigger companies is that new systems, they don't really think about batch processing anymore. You think about stream processing. So that means all the data that is coming in, all the changes is made available on a system like Kafka, something like that. Maybe you use some other modern stream processing system to incrementally update your machine learning models. So there are two aspects to this, right? There is the consumer, you as a data scientist who have to train your machine learning models. Do you even support streaming data, or do you need to update those models in a batched fashion? If you're very sophisticated, you'll build models that can be updated incrementally, and you can provide these updated models to your users much faster. The other side of it is, does your data infrastructure, does it support streaming all of this data, or does it only support a batched fashion? That's probably the aspect that is most interesting for us. We care about streaming data. We care about synchronizing data between different kind of data systems. Right now, we care most about databases. We care about streaming data from a relational database to an ElasticSearch database. But I could definitely see us in the future caring about streaming to other kinds of data systems, such as a data lake, or probably more directly to whatever technology you're using to update your machine learning models. I think that's going to be super interesting.
Yeah. I know we got to wrap up, but related to what you just said, this is something that I didn't really touch on. Well, we didn't touch on real-time. That would have been interesting because I know that's a challenge. Like real-time syncing between different data systems is not straightforward. But also the element of if you have this common layer of GraphQL between your different databases, it unlocks the ability to do pretty straightforward ETL between those databases. So if you have a common schema between your SQL database and your Mongo database and your Elasticsearch cluster, with GraphQL and Prisma, then it's easier to mirror data or import data from different systems. Is that an accurate way of putting it?
This is one of the biggest challenges in enterprises, that you have all of these disparate systems that all have data that is kind of similar, but the shape doesn't match. So let's say you have 10 different systems that all know about an order, but they all contain a subset of an order. And they might not even have the keys that allow you to kind of match them all together. So that is exactly this. It is an entire category of big, complex enterprise software and expensive consultants who help model out your data structure. And I think GraphQL and the schema model has a role to play there, because that's exactly what you do. You map out your domain model, and when you have that, you can start mapping between them and linking all of this up. So I'm really excited about that part.
Okay, Soren. Well, it's been really fun talking to you. We covered a lot of ground and opened a lot of doors that hopefully we can re-explore in the future. I'm excited about what you guys are doing with Prisma. So nice work, and we'll talk soon.
Thanks a lot. It was awesome to be on the show.
Cloud computing can get expensive. If you're spending too much money on your cloud infrastructure, check out Do It International. Do It International helps startups optimize the costs of their workloads across Google Cloud and AWS, so that the startups can spend more time building their new software and less time reducing their cost. Do It International helps clients optimize their costs. And if your cloud bill is over $10,000 per month, you can get a free cost optimization assessment by going to doit-intl.com/sedaily. That's doit-intl.com/sedaily. This assessment will show you how you can save money on your cloud. And Do It International is offering it to our listeners for free. They normally charge $5,000 for this assessment, but Do It International is offering it free to listeners of the show with more than $10,000 in monthly spend. And if you don't know whether or not you're spending $10,000, if your company is that big, there's a good chance you're spending $10,000. So maybe go ask somebody else in the finance department. Do It International is a company that's made up of experts in cloud engineering and optimization. They can help you run your infrastructure more efficiently by helping you use commitments, spot instances, right sizing, and unique purchasing techniques. This to me sounds extremely domain specific, so it makes sense to me from that perspective to hire a team of people who can help you figure out how to implement these techniques. Do It International can help you write more efficient code. They can help you build more efficient infrastructure. They also have their own custom software that they've written, which is a complete cost optimization platform for Google Cloud, and that's available at reoptimize.io as a free service if you want to check out what Do It International is capable of building. Do It International are experts in cloud cost optimization, and if you're spending more than $10,000, you can get a free assessment by going to doit-intl.com/sedaily and see how much money you can save on your cloud deployment.
Wow!